Okay, all right. So this is a new topic. So let's get started. This is a new chapter, basically chapter number 6. Now we have a few things in this chapter. It's not a difficult chapter at all. And things would get better in some time. Okay. All right. So let's talk about the very first thing, that is binomial coefficients. Okay. This is called binomial coefficients. And you guys, if you're practicing questions from like past papers and not like if you're practicing yearlies, so you would, I'm pretty sure that, when you open the past paper, when you start looking at, the very first question is coming from this topic. Okay. So this is the first thing which we need to talk about. Acha. But before that, let's just discuss the context of this chapter, from where exactly it's coming, and how exactly do we deal with this and all of that. Okay. Series basically has a few things in it. Okay. So we will be talking about the first topic, that is binomial coefficients. Then we will be talking about different type of sequences. Okay. For example, let's say if you have 2 plus x whole power squared. How do we expand this? Will we know how to expand this very easily, because we have this identity that we can use, that is the square of first number. It's 2 squared plus 2 multiplied by the first number multiplied by the second number plus the square of the last number. We know how to expand this, right? Let's say the question was 2 plus x whole cubed. I can even expand this as well. How? By writing it this way, 2 plus x into 2 plus x squared. And then I can write the answer of 2 plus x squared, and then I can expand. But what if the question is about expanding 2 plus x whole to the power 10, or whole to the power a very, very big number? Then we would get stuck. Okay. So this is something that we use and we can use as long as we are easily able to manage the question this way. But for bigger values, if you have a bigger value at this point, we need some help, we need some formulas to do that thing very, very quickly. So let's talk about the formulas that we would be using in order to do this correctly. Okay. So imagine that it's a plus b whole power n. Just so the power could be any number. We are just taking n, and a and b could be anything. We are just taking a and b. How do we expand it? It's n c 0 a power n minus 0 b power 0 plus n c 1 a power n minus 1 b power 1 plus n c 2 a power n minus 2 b power 2 plus dot dot dot, and the last term is going to be n c n a power n minus n, b power n. Okay, so obviously this would become 1 and this would also become 1, right? Okay, anyways, but the important part is that even if you have a cubic expression, a quadratic expression, if you have the power as, let's say, it's something very, very big, every time we can use this formula to expand. Let's just quickly practice one thing and then things would get even better. Okay, we don't directly use it for expansion, but yes, we use it for some other purpose. So let's see. Okay, let's talk about this example quickly. So we have 2 minus 3x power 10. Okay, or let me just yeah, 10 is fine. Okay, and you have been asked to find the first 4 terms in the expansion. Okay, the examiner just wants you to find the first 4 terms, not more than that. Okay, how do I do it? So it's nc0, so it would be 10 c0, a is 2 power 10 plus nc1, so I would have 10c1, 2 power n minus 1 is 9, and then 3x is the second number, and I need to write it with the minus sign. Why? Because here we had positive, and when I have negative here, so I'll consider that this negative is basically with my 3x. It's 1 plus the third term is going to be 10c2, 2 power 8, and then minus 3x power 2, and then the fourth term is 10c3, 2 power 7, and minus 3x power 3. And that is it. Now, obviously, I need to find these values, so I will use my calculator directly. Just do 10c0 multiplied by 2 power 10, and this is going to give you 1024 plus the next one 10c1 into 2 power 9 and then multiplied by minus 3. So this is going to give you minus 15,360x plus the third term is going to be 103,680x squared, and then the last term is going to be 414,720x cubed. Now, what is important? Why did I even do this example? First of all, you guys need to understand that what exactly is the application of this topic. Yes, the examiner can ask to expand and find first 4 terms. You would get to find those questions as well. But mainly, he would be interested in asking you to find some specific terms. Okay, so that is more important. We'll talk about that in some time. Other than this, can anyone tell me how many terms would I have in the expansion if the power is n?
Infinite, miss.
Sorry, I was not able to understand anything. Say it now.
Infinite.
Okay, and what about you, Rafe?
Yes, I'm saying, can you repeat the question?
Yeah, the question is that if the power is n, how many terms would we have in the expansion? I'll tell you. Okay, I'll tell you. Look at it. For example, if we have x plus 1 whole squared, how many terms do we have? The first term is x squared plus 2 multiplied by x multiplied by 1 plus 1 squared. We have 1, 2, and 3. We have 3 terms at this point, right? So this means that when my power was 2, I had 3 terms in the expansion. Similarly, when the power would be 10, I would be having 11 terms in the expansion. Yes, I only wrote 4 terms in the expansion for here because the statement was find the first 4 terms in the expansion of 2 minus 3x power 10. Okay, so
You
obviously
have
if you,
plus 1.
yes, very good, n plus 1. So if n is your power, n could be 1, n could be 2, 3, 4, 5, 6, 7, could be any number. If n is your power, you are going to have n plus 1 terms in the expansion. And how is that clear? It's clear from here as well. 0, 1, 2, 3, 4, 5, 6 till n. So from 1 to n we have n terms, and then this 0 term is also a term. So that is why in total we have n plus 1 terms. Okay, this is very, very important. Whenever the power is n, we would be having n plus 1 terms. Okay, the next thing that is important here is that the use of calculator, right? So I've used my calculator to figure out the value of 10C0, 10C1, 10C2, 10C3, and so on. Okay, the calculator was used. Now this was just some idea about this chapter. Just relax. Okay, let's talk about a question that you would get to find in past papers as well. This is what I was talking about. Okay. It says, okay, now let me read the question. When 1 minus x by 3 power n is expanded in ascending powers, the coefficient of x squared is 4. Given that n is the positive integer, find the value of n. Okay, this is basically the question. Okay, so this is the thing. The coefficient of x squared is 4. N is positive. It says find the value of n. Acha, okay. This is the question. Now this time around, we do not have the power and we need to find the power. How do we find it? We need to, first of all, think about the term that would be containing x squared in it. Okay. So just imagine. We won't be doing this question completely. We won't be finding the value of n. This is just a brainstorming session. Just relax. Just think about the fact that which term exactly would be having x squared in it. That is something that we need to think about. Okay. Acha. Forget the value of n. For the first term, we write it down this way. It's nc0, and then it would be 1 power n plus nc2. Then it is 1 power n. Sorry, the second term is basically nc1, 1 power n minus 1, and then it is minus x divided by 3 plus. The third term is going to have nc2, 1 power n minus 2 minus x by 3 power 2. So this is the point where you need to stop. And this is why I mentioned this question. First of all, you need to spot that which term exactly would have x squared in it. Okay. This term does not have x in it. This term, now it has x, but the x is linear. The power of x is 1. And if you look at the third one, the power of x is 2. So from the third term, I can certainly extract x squared. So this means that this term would be having x squared in it. Yes. Any confusions with this?
No, miss.
Yes, Rafe?
It's like it is a plus b whole to the power of n is equal to n and 0 multiplied by a to the power of n plus n and 1, then whole multiplied by a n to the power of, sorry, a to the power of n minus 1 and b to the power of 1. And
Very
then
good.
we will continue the same pattern from the second one, right?
Yes, you are right. Exactly. This is how the formula is. And then what would be the third term? NC2 and 1 or a power n minus 2 and then b power 2. Okay. So
Okay.
this recognition is very important. You need to understand that which term exactly would have x squared only for this situation. Obviously, it could be that your x was in the denominator. After some point, the difficulty level would increase to the extent that you guys would not be able to understand it directly. Like you guys would not be able to understand that if x squared is coming in the third term or if it's coming in the fourth term. So again, we have a formula of similar type that we need to use every time to find out that specific term, because the examiner is only going to ask you for that specific term. Yes, he can ask you to expand in general as well, but most of the times he is going to ask you about some specific term. Okay, so let me write that formula here. The formula is NCR a power n minus r b power r. This is something that we will be using in order to find the specific terms. Now I'll tell you. This time around, we had coefficient of x squared. There would be some other question where the examiner would be saying the coefficient 1 by x. So then you would not be able to recognize by thinking about it this way. It would become very, very difficult, right? So what you will do is you will just keep r as unknown. We will plug in n, we will plug in a, b, everything. And then we are going to extract the x terms, equate it to this part, and then find it out. I'll tell you. Just look at it from here, okay? Acha. This was first method of doing it, method 1. And we were able to forget about this 1 second. Imagine that this is the question, find n. You are not supposed to find n. We are just supposed to recognize that which term exactly has x squared. Is it the first term? Is it second term? Is it third term, fourth term? This is what we need to recognize, okay? So method 1 was easy for this scenario. We were able to find that third term would have x squared in it, okay? We were able to do it directly. Let's talk about method 2 as well, that how exactly method 2 would work. And the power of this is, let's say, given. Let me just write it down. It's 9, okay? Imagine this as your power, okay? Now, how is it going to work? It's 9c. What is the value of r? That is what we need to decide, right? I need to find r just so I can find the number of term that has x squared in it. So NCR, a is 1, a power 9 minus r, and then minus x divided by 3 power r, that is squared. All right. That is R
Miss, what
plus C.
does C
This is R.
represent?
It's basically combination. Like, you know, we will talk about permutations and combinations later on if anyone is stating statistics. But like, I'm pretty sure you guys would have seen this thing this way, like N1 and N2, right? So this N, let's talk about this. This N2 is equal to NC2. If you want to find the value of N2 through your calculator, just do NC2. This button is there on your calculator as well, right? It's right above the division sign. So you'll press shift and you'll press that button and then you would get that C. So
Yes.
whatever you would get for N2 by applying that long formula, you can just do NC2 and you would get the correct answer, okay? Acha. So let's talk about this, okay? So basically I'm using method 2 in order to see that which term exactly has x squared, and this is what I've written. I'm just going to extract the x term out from this, and that is going to be x power r. Now I'm going to equate this x power r to this, that is x squared, and this means that r is basically equal to this 2. R is equal to 2. So this means R is 2. And in which term exactly do we have R equals 2?
Third.
Very good. In the third term, okay? So it's the third term. So I'm pretty sure that this did not went well, and most of you, or like some of you, would be confused in this, but that's completely fine. Even if you guys were able to understand that in this chapter we will be expanding stuff and we will be finding all the terms because we had a specific formula for this since O levels, right? So we know how to do this, but what if it comes with higher powers? So now we know that we have this binomial formula that we use to expand. We know that if power is n, we would be having n plus 1 terms. And then we started the discussion about finding one specific term. And how do we do that? We do that using this formula, and obviously we will use this formula again and again in past paper questions. So then you guys would get to have a better understanding of it. Okay. So tell me if you have something that is like, you know, confusing you or bothering you right now.
Miss, can you like label all of that, like what does N stand for, C stand for, R stand for? Because it's just getting confusing.
Achha, okay, I'll tell you. Wait 1 second. N. 1 second. The best way of doing it would be, so if you have a plus b power n, okay, what is this? This is a question. This would be a question that you have two numbers and then you have its power and you have been asked to expand this thing. What formula do we use? Yes, we use that big formula, but you can also remember the small formula and find the value. So it's n. What is n? N is the power, okay? So n is basically your power. Then C stands for combination, but you would not get to understand it like this. Permutation and combination is a completely different thing. It's a totally different chapter. It's just something that we use in order to find the value of NC1, NC2 and all of that, okay? And then we have R here. R is basically a varying number. So for the first term, R is 0. For the second term, R is 1. Then R is 2. R is 3. R is 4. This is how it is. Then comes the very first thing that we have inside the brackets. That is A. And the power is the difference of these two numbers, N minus R. And then we have the second number, that is B. And then the power is R directly. So what is N? N is the power. That would be given here. What is C? C is just a helping tool that is there on your calculators and we use in order to find the value of n1, n2, n3. Because you're not supposed to leave it like that. You need to find the value as well, okay? So just take out your calculators quickly and tell me the value of 10C2. How do we do it? It's 10, 1, 0. It's 10. Then shift and divide sign. Now you guys would be able to see 10C and then press 2 and then the equal to sign. And that gives you 45, okay? So this is how we use it, okay? Make it quick, Motasam. Just tell me the value of 14C3 quickly. All of you. Munya, Rafe, Motasam, tell me quickly.
364.
Very good. Okay. So this is how we use the calculator in order to find these values. And then the last number, that is basically R. Now, what was the role of R? If you guys remember, in the first term, R was 0. In the second term, R was 1. In the third term, R was 2. It was 0, 1, 2, and so on. So this is how it was going on continuously, right? So either you can remember all that formula, that is a big formula, or you can just remember this part. And obviously we are mature enough to use this thing, plug in the value of R as 0, 1, 2, 3, and so on. And we will be going till n and then expand the thing, okay? So it is your choice. Yes, Rafi, is it okay now?
Yes, miss.
So n is the power, C stands for combination, but forget it because you will be using a calculator directly. And R is a number that is varying, but obviously R has a lot more to do with some other stuff, right? About finding some specific coefficients. For now, we just discussed how to find all the coefficients. The examiner would give you some expression of x and he would say, find the coefficient of x cubed or find the coefficient of 1 by x squared. So at that time, you would have to spend time and see that which coefficient exactly would have x squared or 1 by x cubed. And then you would basically find the mathematical value. So this is what we will be doing in the next class, that is tomorrow, okay?
Okay, miss. Miss, can you send the recordings?
Yeah,
Like
I'll send both the recordings. I know, yes.